All right, we're going to solve for example 3-1. So let's do that here. Uh-oh. I just knock it over. No, we're all right. All right, 3.1 example. So we've got a voltage source. We've got a resistor. We've got another resistor. We've got another going down and a current source. We've got this coming over here. And we've got a resistor in between. And we've got a resistor in between. And so this we've got 10, 5, 5, 10, 2.5, and 0.8. So that's our problem that we've got right now. We're going to try to solve it. So for this strategy here, we're going to look at our nodal analysis. We're going to look at how we can solve a circuit like this, a little simpler than doing 1, 2, 3 different loops. Simpler is better because there's less chance for error there. So we're going to write down also our plan of attack. We got 1, make reference node. So first thing we're going to do is going to make a reference node and make it ground. So I'm going to take this one here and make it ground. So let's call that one yellow. This one we did over here. Okay. Now next, what do we got? We've got, let me change the light a little bit over. Oh, that's better. Next, we're going to do 2 label node voltages. So I was just going to say we're going to find the nodes, which are going to be here, here. You know what? Let's put one here too, because there's something between here and ground, so that counts as something. There's one, there's one, there's one. And that's all the voltages, voltage, voltage, voltage. Okay, because remember, this voltage all over here is the same. You have to have something between it. So there's something between this, and there's something between ground. There's something between this and this. There's something between this and this. There's something between this. No, this is all the same voltage right here. This is all the same. So this one doesn't get its own voltage up here because it'd be the same. There's nothing in between. So we're going to label that. Now we're going to take, let's just highlight what we just did here. Label node voltages. That's here, here, and here. And we're going to call them, let's just V0 for that one, V1, and V2. You know what? We're even going to highlight this part up as well. V0, V1, V2. Now we're going to do 3 draw current arrows coming out of these nodes. Draw current arrows leaving nodes. So I'm going to draw my current arrow coming out. I'm going to draw one coming out. I'm going to draw one coming out. I'm going to draw one coming out. Draw one coming out. Draw one coming out. That looks pretty good, and we know this one coming out is going to go that direction. So let's make that a different color just so you can see there. And we're going to, let's call these something. Let's call this I1, I2, I3, I4, I5, I6. Doesn't really matter. So let's highlight this. So draw current arrows leaving the nodes and label. So that's what we did here. And we labeled it. That's what we did here, and we labeled it I3, I1, I2. That one's whatever. Or that one's not going to matter. I'm just going to call that one I. Actually, it's going to be I2 in the reverse, but whatever. Did I miss anything? No, we have I4 over here too. Okay. So, we got that part. Let's do the next part. We're going to go for 4. This is a nice tip. Solve easy nodes. What's the easy node mean? That means there's not a whole bunch of them. That means easy ones. Let's make this in green. What's an easy node? This is an easy node. That's a real easy node. What is the voltage there? It has to pass between a 10-volt source to get to ground, so V0 has to equal 10. We solved one of them already. All right. So now, let's see, any other easy ones? No. So now we're going to do 5. We're going to do KCL at other nodes. So the other nodes are here and here. We've got 2 other nodes. Let's take this first one. Now what we're going to do, at node V1, that's where we are here. That's where we are here. We're going to do our current law, I1 plus I2 plus I3 equals 0. I1 plus I2 plus I3 equals 0. And now we know V equals IR, right? V equals IR. And we already know this law there, Ohm's law. So now we're going to solve for I1. So I1 is going from V1 to 0 over this resistor. So what we're going to do here is I1 is going to be V1 over 5 because it's the voltage. What has to happen to this voltage? It has to pass through a 5 ohm resistor before it hits ground and becomes 0. So that's how we write this one. And now we're going to do I2. I2, we go from V1 minus V0. So I'm going to do V1 minus V0. And then over whatever's in between them, which is 5. And we're doing V1 minus V0, so the one we're at to the one we're not going to, because that's the direction we've done with step number 3, where we draw the currents out of all the nodes. So you want to make sure you follow this procedure. Currents coming out, and then you can do V1 minus V0. This way you don't flip them up and mess them up and do V0 minus V1, because you're not going to get the right answer then. So V1 over 5, because it's all it's passing through. We've got V1 minus V0, V1 minus V0 over 5. And then we're going to get plus, and now we got the last piece over here. We've got V1 minus V2 over 10. V1 minus V2 over 10 equals 0. So now what do we have to do with this equation? Well, we want to bring this into like a standardized form. So I see that as your largest denominator. So if we multiply everything by 10, we should come up with something that looks a little nicer. So if we multiply this by 10, we're going to get 2V1 plus this by 10. We're going to get 2V1 minus V0. Then by this one, we're going to get plus V1 minus V2 equals 0. That's going to be our equation there. What's that going to simplify out? We've got 2V1, 4V1, 5V1. Let's just write it down here. 5V1 plus, what do we got? We got negative V2. Negative V2 equals, we got 2 times V0, which is 2 times 10 equals 20. That's going to be our equation for the first one. Okay, that's easy. Now what are we going to do? We're going to do at node V2. Node V2. Node V2, we've got I4 plus I5 plus I6 equals 0. I4 plus I5 plus I6 equals 0. So I4 is going to be the one coming, yeah, we drew it this way. Okay, we'll take that. So it's going to be V2 minus V1 over, what is that, 10? I think that's 10. V2 minus V1 over 10. Okay, and then we're going to do our next one. What is I5? It's going to be V2 minus 0 over 2.5. So V2 over 2.5. Cool. Then we've got our last one, V6. Our V6 is going to be equal, oh look, it's exactly the opposite of this thing. This is the current coming in. So it's going to be negative 0.8 equals 0. So let's multiply this one out by 10 and try to solve up. We're going to get 10 times V2 minus 10 times V1 plus 10 divided by 2.5 V2. So that's going to be what? V2 minus V1 plus 4 V2 equals 0.8 times 10 equals 8. And so we're going to get 5 V2 minus V1 equals 8. That's our second equation. Two equations, two unknowns. That's because we knocked this first one out early on. Uh-oh. I've been talking, you guys couldn't see that. Well, I'll give you a second to kind of catch up. So just to talk through what I did here. I4 plus I5 plus I6. That's up here at this part. I4, I5, I6. We had the V2 minus V1 over 10 because when we go from here to here, we have V2 minus V1 over the resistor in between. Do that the same again over here. We've got V2 minus 0 over 2.5. V2 minus 0 over 2.5. And we got negative 0.8 because, again, this is current going in. We're saying it's coming out. There's nothing in between, so we know what that current is. It's negative 0.8. Cool. All right, so now we're caught up. So now to solve this thing, we're going to do what? We're going to do our little matrix thing. V1, V2, number. So we've got our little box for this. We've got our box for this equals box for this. Okay? So now our V1s, we're going to go from here. We got 5 V1 from this one. We've got minus 1. We've got 20. Let's look at down here. We've got minus 1. We've got 5. We've got 8. So A minus B in your calculator times A minus 1 times B is going to pump out the answer of 4.5 and 2.5, and this equals again V1, and this again equals V2. That's your solution set, those two. And then if we're I think the problem asks for power as well. So if we want to get some power out of that, all we have to do is we got to do Ohm's law first. V equals IR. We've got 2.5 equals I times 2.5. Okay, that's going to be equal to I equals 1. And then we're going to do P equals IV. P equals 1 times 2.5 volts equals 2.5 watts. Nice and easy. Solve through that whole one. We'll box that up there. Okay. So I think that's pretty much it. That is showing us the power going through the 2.5 watt resistor. KCL, other notes. We should highlight that just for kicks, just to kind of get an idea. Let me see if I have another color. This is close enough. That's like dark blue. So that's our KCL, and that's our KCL too. Cool. So I think that is how we solve these. Let's try again for another one.